Hi, my name is Dachary. I'm a senior documentarian on a developer documentation team. What that means is that we write code examples and example applications in addition to the documentation for our products. Today, I want to talk to you about code examples and documentation. Specifically, we'll talk about how my team tests, extracts, and transcludes code examples in our documentation. For this talk, we're going to look at what it means to have code examples in docs, why that's important. We'll look at how code examples and documentation can go wrong. We'll explore the adaptive code example testing process that my team has developed over time to test the code examples in our documentation. And we'll look at how we extract and transclude the code examples out of our test suites and into our documentation. This will be a sort of high-level whirlwind tour of how my team works, and this is a very deep topic we could go in a lot more detail on, so I'd love to hear any questions you might have in the comments or reach out to me. I'm happy to talk further about any of this. Let's look at code examples in documentation and why that's important. When your product is code, your documentation is also code. Developers need that code. If your product is an SDK or an API that developers use by writing code, your documentation has to include code examples. On the left side of this slide is one of the pages in our documentation. We have a procedure here, and each step of the procedure has a code example that illustrates what you need to do during that step, along with text that describes what's happening in the code example. With a basic level set about why code examples are important in documentation, let's look at how those code examples can go wrong. Developers don't just need code in your documentation. When your product requires developers to write code, the code in your documentation has to be working code. When the code in your documentation doesn't work, developers think your product doesn't work, they think they're too stupid to use your product, or they just get frustrated and churn. In any of these cases, it can cost you reputational damage when developers share the failures in your documentation, or they can actually cost your organization money when developers move on and find another product that works better. I've categorized the working code and sort of types of issues that can happen in your code examples into two categories. One I'm calling table stakes for working code. Every code example in your documentation has to pass this bar. And the next category is sort of reputation builders. These are nice to have that can help developers succeed faster with your product, but they're not necessarily a bare minimum requirement. And there can be more subjective requirements in that second category. So let's look at table stakes. Your code examples have to be typo-free. That's really basic. The API names in your code examples have to be valid API names. In this code example on the left, I've highlighted a line, error, handle sync error. This is a code example that is live in our documentation right now, and that line is incorrect. The actual parameter name should be on error, and we do get feedback on our documentation about this problem. Your code example shouldn't be missing any brackets, parentheses, or semicolons, and your code example should have the correct number of arguments of the correct types. There are a number of times when we are handed code examples by engineering teams that were created early in the technical design process, and API names may have changed, or the number of arguments or argument types may have changed between the design process and the implementation. So your code examples have to work against the implementation. They can't be based on the design, and they have to incorporate any updates to the design. The second category of items here, I've called reputation builders. They can help developers succeed faster with your product, but they can be a little more subjective. This includes things like good variable names. A lot of times, developers write code examples that include variable names like foo or string column that aren't really illustrative of how to use your product. The code example should illustrate your intended usage, ideally. Going back to this example from our documentation page, this feature is designed for heavy insert-only workloads, and the main use case for this feature are things like point-of-sale terminals or Internet of Things devices. So in the code example here, we've chosen to use a weather sensor reading as a code example to illustrate that this is intended for use with Internet of Things devices. The code examples should include some surrounding context. Now, this one particularly can be very subjective. There are some developers who only want to see the API name or method call in the code example with maybe the correct number of arguments and the argument types. There are other developers who really want to see all of the setup context, including things like initializing every variable that's used in the code example, and even error handling or validation. Because this can vary a lot across developer audiences, most organizations pick one aspect or one level of context and show that consistently. Ideally, you're consistent. It can be difficult to do that. Your code examples can't just work at the moment they're created. They have to work now. This is a problem because code changes. With every commit that developers make to a code base, code that used to work may stop working. Code can stop working for reasons like deprecated APIs, changes in error handling, breaking changes made to pave the way for new features, or, we're all human, bugs ship to production sometimes, regressions. You need validation on an ongoing basis that code examples still work, not just at the moment they were created. In many cases, my team is able to catch one or more of these issues by rerunning our test suite with the new release version. So, I've sort of hinted at burying the lead here. You should test your code examples. Let's look at how my team has evolved this process over time. When my team started testing code examples, we relied on the compiler to verify API and argument correctness for free. So we would write our code examples in an IDE or have it actually checked by a compiler to verify that we're using the right API names and our arguments are correct and we have the correct number of arguments. That can get you a long way as a good starting point, but that doesn't necessarily give you the assurance that all of your code examples actually work. Going back to this example that's incorrect in our documentation, this is actually written in a test suite. This particular example is in a test that is skipped due to the way jest works and some interesting things about JavaScript. There is no indication to us that this error parameter is actually incorrect. So the compiler doesn't always tell you all the problems. Over time, my team has started building out more detailed tests for the code examples that we include in our documentation. These tests let us verify the accuracy of our documentation through test framework assertions like a developer would. In Xcode, the example that I've screenshotted here, our code examples use expectations and the XC test framework assertions to verify that the code examples in our docs actually do what we say they're doing. This lets us explore the problem space through code like a developer and uncover any edge cases or gotchas. Going back to the procedure at the beginning of this talk, when the engineering teams handed that functionality off to us, there are some important details they forgot to tell us about how that functionality worked. We never would have uncovered those details if we didn't write our code examples in test suites. We were able to communicate effectively with customers about those edge cases or those additional things that engineering didn't think about, and we were able to save the developers problems and troubleshooting by adding those extra contextual details. When I spend an extra 2 hours trying to figure out a code example and make sure it actually works the way we say it does, I'm saving hundreds or thousands of developer hours. And another nice thing about testing the code examples in unit test suites is that tests can be rerun when the product versions change. So you don't just get a guarantee that the test was correct when the code example was written. You can update a version and check all of your tests again and find out all of your code examples still work, or maybe there were changes introduced with the version that broke some of your code examples, so you need to rework them. My team uses platform idiomatic testing tools to actually test our code examples. We have 9 SDKs in a variety of language, so what this means is we actually have more than 9 unit test suites that we use to test our documentation. We have them in an example directory that lives outside of our documentation source. Here, I've expanded our C++ examples. You can actually see in this directory, I have 3 different test suites. We have an asymmetric test suite, a local test suite, and a sync test suite, as well as some scripts that we use when we test our code examples. In C++, we use CMake and Catch2 to test our code examples. In iOS, we use Xcode to test our code examples. In Kotlin, we use Android Studio. In Node, we use Jest. So we are using platform idiomatic test suites just like our developers do. This lets us better understand how our product works and also gives us a basis for writing documentation for our developers about how to test their own code that uses our product. In addition to running the tests in the unit test suites, we also use GitHub workflows to run the test suites on pull requests where we update those tests. So you see here in the left, there is a GitHub workflow that runs our C++ local unit test suite. when there's a change to any file in the CPP local directory, so if I update a code example in that test suite, then this will automatically run the test suite and post the result on the pull request. You can see on the right here, I have a couple of failing tests on one of these pull requests that will actually block merging the pull request until we fix the tests. This sort of gives us a backup mechanism to use the CI to automatically test examples so that if we forget to run the test locally, or maybe I only run one test file and the failure is in a different test file, we get that sort of extra validation every time we make changes to our tests. So now we understand a little bit about how my team tests our code examples. Let's look at how you get the code examples out of the test suites and into the documentation. We really want to avoid manually copy and pasting our code examples because that's how we sort of get into a lot of the problems we talked about in the beginning as table stakes errors that can occur in your code examples. In this case, things like missing punctuation, failing to copy some of the context, or forgetting to update the code example when there are changes in the directory. We have written an open source public tool called Bluehawk to help us extract those code examples. Bluehawk has two components. There is a markup syntax that you use in your test files to indicate what content you want to extract from the test, and it also has a command line tool that gives you a series of commands you can run to specify additional options when you actually extract the code. So in this slide on the left here, you can see I've highlighted some snippet start and snippet end tags. That is Bluehawk syntax to create a code snippet. There's an identifier there, so this is going to be a code example named async await in the context of this particular file. And you can see that I'm starting that snippet after I'm setting a test expectation. We don't need to show our developer audience our test framework assertions, but we do want to show them the actual code that performs the operation. You can see further down, I've got a remove start and remove end tag. Those Bluehawk elements will remove that expectation fulfill that's there for me to know that my test works properly, so that it doesn't have to appear in the output code example that developers see on the page. And then I'm ending the snippet before I do the actual test methods that cause this test to run. On the right, you see an example of the code that is extracted from this file using the Bluehawk syntax. So as you can see, it starts with that login function declaration, and in the do block, it has removed the expectation fulfill that we use to know that our code example worked properly. As I mentioned before, our unit test suites live in example directory outside of our documentation content source directory. We use Bluehawk to extract our code examples that we want to show in the documentation into a generated directory that lives inside our source content. This way we know everything in the generated directory was automatically generated using Bluehawk, and we don't manually update any of those files. If we need to make changes to any of the code examples, we go to the examples directory and find the file that was used to generate the code example. This way we're not manually updating something that has been generated automatically, and when we regenerate things in the future, we don't accidentally overwrite any changes that we make. With this combination of markup tags and CLI commands, Bluehawk can do a lot of cool stuff. We saw the syntax you would use to remove elements from a page. Bluehawk can also replace elements. So for example, in our Swift unit test suite, we have some namespace collision issues. So we have some really gnarly object names like flexible sync _ dog. We use Bluehawk to replace that and just call it a dog in the extracted code example. Bluehawk has the ability to uncomment elements that you might have needed to comment out so they don't actually execute during the test execution. And Bluehawk can extract a range of content in a file as part of a particular state. We might use this, for example, in tutorials. We might have a start state with a comment that says, to do, write a function that performs an insert in the database. And then you might have a final state that actually shows what that function would look like. So you can use Bluehawk to generate both of those files from the same source file using the state command. In terms of CLI commands, Bluehawk has the ability to check for syntax errors in a file. So you can find out if you've made any markup syntax issues when you run Bluehawk. It will allow you to copy files, whether or not you have annotated them for Bluehawk markup. We use this, for example, in some of our example applications. We might have some Bluehawk markup changing elements in some of our files, but not others. But for the application we need to copy every file in the directory, Bluehawk can do that for us. And we can also ignore files. For example, in the C++ test suite I showed you earlier, I want to ignore the build directory. So Bluehawk has the option to let me ignore that when I run the snip command. So now we've got the code examples out of our test suites. How do we get them into the documentation? This is where transclusion comes in. Transclude is a $5 word that I learned when Ben Perlmutter gave his really cool Unit Test the Docs talk at Write the Docs Portland in 2022. I'll link to that at the end of this presentation and also in the comments below. Transclude means I'm including the contents of the file and there's a translation step involved. So let's take a look at how we do this in my organization. In my organization, our documentation is written in restructured text, RST. So we use restructured text directives to transclude our code example files. On the left, we have that same procedure I showed you earlier with the code example in line in the page content. In the right, I have highlighted the literal include directive that we use to include that code example in the documentation. It has a file path to the generated directory, and whenever we rebuild the documentation set, it pulls the content from this particular file in this path and includes it in the documentation as a code example. This is really handy because it means we don't have to manually update any page when we make updates to our code examples. All of our literal include directives point to a file path, so if we update the code example at the file path, the page automatically gets updated for free the next time we publish the documentation. This is really useful for cases where we have the same code example in more than one place in our documentation. For example, in this left-hand side, this example of a weather sensor reading, I have on another page about how you define object models using our product. So when I make a change to this code example, it will show up on this page and on the corresponding page because we're using the same file path with the literal include directive to pull the content out of that code example. And that's it. Thank you for joining me for this whirlwind tour of why you should test code examples in your documentation, how you might get started doing that, how you might take it to the next level, and how my team does it. I've provided a few resources here, which I will link to in the YouTube description. We have our unit test suites, which are in a public documentation repository. You're welcome to look at them and see examples of how we do this. We have the Bluehawk documentation, which is hosted on GitHub. And we have a link here to Ben's Unit Test the Docs talk at Write the Docs, which goes into a little more detail about some of these elements.